I will explain about variable threshold CMOS circuit. Variable threshold CMOS circuit. Here you can see this. As you know that this is the inverter circuit. This is the inverter, CMOS inverter. While giving 1, we need to get 0 output. Of course, we'll get, and we know that the operation. And while giving 0, it should get, that is 1 output. 1 output. So while just assume before variable threshold voltage, just assume it is having 0.6 volts threshold, and it is also having just 0.6 volts threshold voltage. When it will respond, when the input voltage or VGS is should be greater than threshold 0.6 volts, then only it will respond and will get the required either 0 or 1 output. And there is no problem here, of course, but it consumes more power here. In this case, it consumes, that is because the threshold voltages are fixed, and it consumes more power. This is the traditional method. But our aim is always in VLSI need to reduce the power consumption. So that here we are using some extra biasing, extra power supply to the bias body, and we can reduce the 0.6 volts to 0.2 volts. Just assume. And here also by using extra biasing, we are reducing 0.6 to 0.2. With this, we can increase the speed of the circuit or your processor, your mobile processor or RAM or anything, because the processor will design with millions of transistors inside. RAM is designed with millions of transistors. So if you are reducing here, that is by using extra biasing, so we can reduce the power consumption. Of course, the speed of the processor will increase because of this threshold method, variable threshold method. So this is the extra biasing we are giving, either forward or reverse biases voltages, that is forward body bias or reverse body bias effects. I will give here. We know that how they are designing a transistor, so or inverter. Here you can see this. This is only the circuit. This is only the circuit for CMOS. But the fabrication process, we know that fabrication process. This is only the circuit. Here we can take V out, and here we are giving V in. But how the fabrication process is going on, as you know that either N-well or P-well process using to design a transistor, that is inverter, CMOS inverter. If you take P substrate material is having holes, so that by heating this material we are inserting electrons, that is named as N-well. And to design gate terminal, we are depositing polysilicon material at the middle of the substrate, and that is named as gate. And here also need to design a gate terminal and deposited polysilicon material, this is also gate 2. And to design left side transistor, diffuse the electrons because it is a holes material already. So that's why by heating this material we are inserting electrons, and that is named as source and gate, and this is named as drain. Similarly here, to design a source and drain terminal, diffuse the holes, and it is named as source and drain terminal. This is also source and gate, and this is the drain terminal. This can be used as a CMOS inverter. This is the fabrication process to design a gate terminal, of course. And here we are giving the extra biasing. Here we are giving that is body biasing, extra biasing we are giving, and extra biasing we are giving, and using that we can control, we can reduce the threshold voltage for this, and we can reduce the threshold voltage for this, and we can reduce or increase. Either using forward bias you can increase, you can reduce, and you can reverse bias, you can decrease the threshold voltages for the transistor, two transistor, one is NMOS and one is PMOS transistors. So here you can see this, that is the same thing here, and here it is variable threshold parameter, threshold voltage is variable in VTMOS. In traditional it is fixed. leakage power is high in normal conventional method, but leakage power is very low in variable threshold method, MOS circuit. Active speed is normal, but with the reducing threshold the transistor will respond quickly, that's why the speed is very high. And standby power is high, here it is low, and complexity is more, but in variable threshold, because we are giving extra power supply for body bias. And battery life is more in variable threshold method, but in traditional it is very less because it consumes more power. Thank you.